My name is Andrew Davies, and I'd like to thank the University of Colorado Denver School of Medicine for providing me with such a fantastic research facility for conducting my research on repair of spinal cord injuries.
Dr. Stephen Davies brought his world-renowned research lab to Colorado when he learned of the remarkable opportunities at the new Anschutz Medical Campus.
When I entered the field of central nervous system regeneration back in the late 90s, it was a field that people thought in general wasn't going anywhere. No one was able to get regeneration of the spinal cord. However, I conducted some experiments where we transplanted adult neurons directly into adult central nervous system. It's the real Frankenstein experiment, adult-to-adult transplantation. And to our great surprise, we found that adult neurons were able to send new nerve fibers from one side of the brain to the other in just 1 week.
Public awareness of spinal cord injury grew exponentially when Christopher Reeve, known for the movie Superman, suffered a devastating accident.
I was only 29 years of age and a graduate student when Christopher Reeve had his spinal cord injury. So at that time, the new technologies that we've now developed obviously weren't available, but the foundation that he set up has been instrumental in allowing us to conduct our research, to develop these new therapies. I think if he was alive today, there would be a far better prognosis for his gaining recovery of function again, particularly hopefully with the use of the new therapies that we're developing. So what we've been doing is developing a new stem cell technology to make the right kind of early support cells called astrocytes that we can then transplant into a spinal cord injury and promote regeneration and recovery. Astrocytes are almost one of the forgotten cells of the nervous system. It's estimated that 70% of the nervous system is made of astrocytes, star cells, and very little is known about different types of astrocyte. But we know that they form scar tissue after a spinal cord injury, and we also know that they're involved in onset of neuropathic pain, a major problem that can arise when somebody has a severe traumatic injury, spinal cord injury. So we are the first lab to be able to make different kinds of astrocyte from stem cells. They're called glial restricted precursors. What we think we've discovered is that it's a subtype of astrocyte that's causing the problem. Not all astrocytes will promote pain after spinal cord injury, and there's a good type of astrocyte that will give us all the recovery, all without any problems, all gain and no pain. We have seen remarkable levels of recovery of locomotion in rats that received our GDA cells. So we're at the moment quietly confident that we've discovered what could be considered the gold standard cell for promoting repair of the injured spinal cord, and that we now know we can make the human form of these cells. And we are hoping that these cells will therefore translate to clinical trial and be as effective in humans as we've seen these cells can be in rats.
My belief and my hope for Dr. Davies' research is that I will walk again someday. I believe that his science, from bench to bedside, will allow me a full recovery from the accident that rendered me a quadriplegic 8 years ago.
The new technologies that we're developing for repairing spinal cord injury, they're not only applicable to the spinal cord, they're also applicable to repair of the whole central nervous system. So we are also investigating the potential of our cells, our GDA cells and Decarin for repair of stroke, or for promoting recovery in neurodegenerative diseases like Alzheimer's and Parkinson's. And so in general, looking at repairing the nervous system, repairing the spinal cord, we're developing new therapies for repairing all damage to the nervous system. The goal of all this hard work, my hard work and that of my research team, is to develop new therapies that can really make a difference to people's lives, those that have suffered severe spinal cord injuries. So I will die a happy man if these therapies are translated to clinical trial and prove to be truly effective at alleviating the terrible suffering of spinal cord injuries.